Hello everyone, welcome to Gate Academy. Will it run if slip ring induction motor is fed from the rotor side? Let's see that. Let's a p-pole slip ring induction motor in which the stator terminals are short circuited, where the supply, three-phase balance supply is provided to rotor side with the help of slip ring and carbon brushes. A three-phase balance supply is provided to the rotor, that is IA, IB, IC of F frequency. Let's understand this particular topic with the help of our helicopter method. In this, let a stator is a station, rotor be a train, a man is walking over the train be a rotor magnetic field, and a helicopter, that is stator magnetic field. Now, if three-phase balance supply is provided to rotor of F frequency, a rotating magnetic field is developed which rotates with respect to rotor at a speed of ns equal to 120 f upon p in a particular direction. When this rotating magnetic field initially when the rotor is stationary, that is rotor is not rotating, this rotating magnetic field interacts with the winding of stator. So there is an induced EMF because stator winding is stationary and rotating magnetic field is rotating of the rotor. It interacts with the winding of the stator. So there is an induced EMF. As circuit is closed, induced current flows. According to the Lenz's law, the induced current would flow in such a direction so that it opposes the very cause of its production. What is the cause of production? The cause of production is that rotor is stationary, the rotating magnetic field with respect to stator is the relative speed between the rotor magnetic field and the stator is ns. So rotor should be rotate in a particular direction so that the relative speed between the rotor magnetic field and the stator should be reduced. If rotor starts rotating in the same direction to that of the rotor magnetic field, so the relative speed between the man and the station increases, because train and the man which is standing over the train are moving in the same direction. So the relative speed between the man and the station is same, that is it increases. If rotor starts rotating in the opposite direction to that of the rotating magnetic field of the rotor, so the relative speed between the man and the station decreases, and that Lenz's law states. Lenz's law states that it opposes the very cause of its production. Hence, rotor starts rotating in the opposite direction to that of the rotating magnetic field. That's why the relative speed between the rotor magnetic field and the stator decreases. If rotor is rotating at a speed of nr, so the relative speed between the rotor magnetic field and stator becomes ns minus nr, that is equal to sns. Now, the frequency of induced EMF in the stator winding is F2. F2 is equal to SF. As the stator also carries three-phase balance winding, if three-phase balance current of F2 frequency flows, so stator magnetic field develop which also rotate in the same direction to that the rotor magnetic field with the speed of sns. That means in slip ring induction motor, if three-phase balance supply is provided to rotor instead of the stator and stator terminals are kept short circuited, then rotor starts rotating but in opposite direction to that of the magnetic field. That means rotor rotates. Thank you so much.